Okay.
Okay, yes,
So
speak.
light travels in a straight line,
Okay,
and when light bounces back off like from an object, it is called reflection.
okay,
And when sunlight, what do you call? So give me 1 minute.
okay, it's
There
okay.
are two laws of light. One is light angle of incident and angle of phase equal.
Angular reflection is equal. Okay, that's okay. Next one is
And
what? No, it's okay, it's
okay,
okay. I was just testing the basic knowledge. What is the chemical formula for the table salt? Table salt, you know, that we use in our home.
yes, sir.
So what is the chemical formula for this one?
So I'm not sure. Is it NaCl?
Okay, means why you are just saying that it is an NaCl? Why did you predict? Have you heard about it somewhere?
Yes, sir. Like in my previous class, I
Yeah,
have
it
heard
is.
of NaCl.
It is. Yes, it is. What is the chemical symbol for water?
Sir, H2O,
Which of the following element is a metal?
sodium.
Sodium. Okay, next. Uh, what is the what is which of the following is a non-metal?
Sir, carbon.
Okay, why do you say that carbon? What are metals and
Carbon.
non-metals? Can you answer me that what are metals?
So metals are like a basic form of matters which can't be like broken down further.
That are elements.
That are
That are
elements.
elements. Means elements we have divided into any metals, whether metals or not. Elements we have divided into two parts. One is metals, other one is non-metals.
Yes, sir.
Non-metals, if we talk that non-metals are generally bad conductor of electricity. Okay, and non-metals are not shiny, they are dull, they have low melting and boiling points. Generally, they are gases or solid. But metals are good conductor of electricity. Okay, they are sonorous, they produce sound on striking. So that you have studied in the 8th standard. So that's why I put these questions here. Okay, what is the chemical formula of oxygen gas? Chemical formula.
Oxygen. O2.
Next, what is the process of conversion of water vapor?
Into liquid.
Hmm?
Sir, is it B, condensation?
So when we are changing, if we are changing solid directly to gas without going into the liquid state, what is it called?
Sublimation.
Yes, it is sublimation. Shabash. Sublimation. It is sublimation. Good. Next. Which gas is produced when metals react with an acids?
Mm,
Think about it. Which gas is produced when metals react with acids?
hydrogen.
Try it. Is it oxygen gas? No. Okay, I'm going to give you a simple answer. इन दोनों में से एक है, बताइए कौन सी है? अच्छा, name an acid. Name an acid.
Citric acid.
Or and the formula of that acid. Name an acid which you know the formula of that one also.
So I'm not good at it. I don't know.
Do you know the name of any acid like hydrochloric acid,
Yeah,
sulfuric acid? Have you heard about it? So what is the
hydrochloric
formula?
acid.
What
Yes.
is the formula of hydrochloric acid? It is HCl. Formula of sulfuric acid? H2SO4. Formula of nitric acid, HNO3. They all are having hydrogens. So when they react with metals,
They
they will
produce
form
hydrogen.
zinc chloride plus hydrogen gas. Okay. So
Okay, sir.
simple. Hydrogen gas is the correct answer. Okay. Because acids contain hydrogens. Next, explain the difference between
So physical change is described as a when an object change its like shape or something without changing its actual properties. Whereas in physics, sorry, in chemical change, it's like the properties of a metal or that object also changes.
properties is also changes. Okay. Okay. So we shall be going to discuss this one also in detail. Next one.
Matter.
Define
So
that.
matter
Define. Hmm.
matter is something which occupies space and has sorry, which has mass and occupies space.
Define matter. Okay. Next one.
Okay. Uh, Describe. So how should I describe the atom? Like, what is atom? Like that?
No. I'm asking that what are the subatomic particle of atom? Name the subatomic particle of an atom.
Proton and electron.
And neutron. And what are their
Yeah,
charges?
proton is positive and electron is negative, and neutron is what we call like the balance of electron and proton.
Yeah, it
If
is neutral, zero. Yeah,
yeah,
good.
neutral.
Why do solids have high melting and boiling point?
Mm,
Any idea? Why do solids have?
because it takes time and the force of attraction is there, so that the molecules are very tightly packed, and to what we call to mm,
They are
so can
tightly
you give me
packed and
one?
yeah.
Yeah, to weaken their force of attraction, we have to put a high melting point or the boiling point.
Shabash. Good, very good. Simply, we need to provide large amount of energy to overcome that force of attraction because they are tightly packed. They have high force of attraction between their particles. Very good. Good. So I'm going to give you. Mm, you have given sodium chloride. You asked me simply when you were saying, but you give this. I'm giving you 15 out of 16. Good. Okay. Okay. So let's start with the chapter. Okay. Now we shall be going to discuss first what is chemical change and physical change in detail, and then we shall be moving further after understanding this one concept. Okay. because chemical change and physical change is easy concept. The students may not be confused in this one. Then we shall be moving further. Okay. So what is chemical change? What is chemical change? Can you guess? What is chemical change?
When when a change is taking place and their property also changes.
Hmm. We'll simply say that chemical change is the change in which a new substance is formed. A new substance is formed. New substance means that simply we can say that a change in which a substance with having entirely different chemical properties is formed. Means a new substance is formed. Now, what for me, a substance can be a new substance, and for Gauri, it cannot be. For example, if I'm saying that I dissolve sugar in glass of water, okay, and it is sweet in taste. So for me, I'm saying that it is a new substance. And for Gauri is saying that no, it is not a new substance. So who will decide that who is correct? There must be some parameters now to measure that whether Gauri is correct, that she is saying that a salt solution or a sugar solution is not a new substance. When you are dissolving sugar into it, it is not a new substance. Or for me, it is a new substance because I know that water is not sweet, but sugar solution is sweet. So I can say that it is a new substance. But who will decide? So there is a criteria to decide whether something is a new substance or not. And what is that criteria? That criteria is that the substance, the substance that is formed must not show the properties of its constituents. What I'm saying here, repeat my statement, that the new substance that is formed is not going to show the property of its constituent from which it is made up of. Like for example, if I'm taking an example of water, hydrogen gas when react with oxygen gas, it simply gives you water. Water is a liquid, okay? They will gives you water. But if you see this one, that what is water? Hydrogen gas. What? How does? Can you tell me that what is the property of hydrogen gas? It is a gas first of all, and you know that it can burn easily.
Yeah.
So it act as a fuel. It is highly flammable. It act as fuel. Okay. Next is, if I'm talking about the oxygen gas. Without oxygen, can you burn anything? If there
No.
is no oxygen, you can't burn anything. So it help in extinguishing the fire. It help in extinguishing fire. Okay. But what does this do? Simply, we can say that this water is not showing the property. Means water should be highly flammable, na? Water should be highly flammable
Highly
because it is
flammable.
carrying hydrogen, which is a fuel, and oxygen. But do water combust? Do water burns? No.
No.
Even if you put the water on a burning flame, it will let it to extinguish. Okay. So we'll simply say that it will extinguish the fire. It will extinguish the fire. So here, it is a new substance because it is not showing the properties of its constant from which it is made up of. It is entirely a new substance. Its melting point, its boiling point, its surface tension, everything is different. Okay. Water is made up of hydrogen and oxygen. It carries hydrogen and oxygen, but it does not show the properties of it, any one of them. Like for example, another example, if I'm taking carbon, if you see that carbon when burns in the presence of oxygen, it will gives you carbon dioxide. First of all, carbon can act as a fuel. Okay, carbon act as a fuel.
Fuel.
You can burn carbon. Carbon is a coal, which you can burn it easily. Next one is oxygen. Oxygen is a lifeline gas. Lifeline gas. You know that every living organism who does aerobic respiration inhale oxygen. But what should the carbon dioxide does? Not burn. It does not burn. Yeah, I'm बोलेंगे. It doesn't burn, nor it act as lifeline gas. Are you getting my point? Does carbon dioxide burn? No. Even
No, sir.
even if you pour the carbon dioxide on a burning something, it let it to extinguish that one. That's why we use CO2, carbon dioxide on the burning flame, carbon dioxide cylinders for burning, for extinguishing the fire. Okay, because carbon dioxide is heavy, so it is not flammable, but it is letting, means it is not acting as a fuel. Moreover, it is having oxygen also. But can you, when you are inhaling the oxygen, carbon dioxide, sorry, will you be able to survive? No, you will not be able to survive, because still it is having two oxygen molecule, but you will not be able to survive because it is a different substance. It is not showing the property of its constant. Are you getting my point? Similarly, rusting, if you're taking the formula for rusting of iron, Fe when react with H2O will gives you plus oxygen gas will gives you Fe3O4 dot XH2O. Fe2O3, FeO, Fe2O3, Fe2O3 dot XH2O. So this is the formula of rusting. But iron, it will not have the same tensile strength. It will not show that property that this and this is a different substance. So we will simply say that rusting is also, or corrosion is also a chemical change. Are you getting my point? Now, what is the physical change? Physical change, the change in which,
No new substances formed.
yeah, no new substance is formed, and the constituent still shows their property. And the constant still shows their property. Like for example, if you take some glass of water, you take some glass of water, you add some sugar to it. When you add sugar to it, will you means how it tastes? It will be sweet.
Yeah.
When you take a sip of water from it, added sugar, so you will simply feel it is sweet. Will you be feel that this sweetening taste is in water or sweetening taste is in milk?
What, sir?
I'm asking that if you add some sugar in water, do you feel that you are drinking milk?
No.
You will simply say that it is water with sugar. What is
Yeah.
the property of sugar? Sugar has a property of sweetening. Still, it is showing its property after it is dissolved. It is still sweetening the substance. It is still showing the property. Even if you add some salt to it, it will be now the solution will be salty as well as sweet, showing both the properties. So as much as substance you are adding into it, like lemon, they all will start adding their eggs. Okay. So simply we can say that a physical change is a change in which a no new substance is formed, and the constituent shows their property after the change. Like you have a paper. This is a paper. You tore it into two parts. Still, this paper and this paper, they both are paper, no? Does they become metal? Does they become some new substance? No. Still, it is a paper though. We have just tore it out, but it does not mean that it is a new substance. Got it? Are you getting my point?
Yes, sir.
So this is physical change. So please start writing this one. Chemical change. First we'll let you write down the definition. The change in which I'm just writing it further. Chemical properties from its constituent. So from here, you have to start writing this one. Yes. Sorry, but I just got an important call. That's fine. Are you there?
Yes, sir.
Are you noted this one?
Yes, sir. Done.
So have you noted each and everything like H2 act as a fuel, this equations, everything?
Yes, sir.
Why have you turned off your camera? Turn it on.
Okay.
Now start doing this one. Note it down fast. It's an example of rusting. And whenever a chemical change take place, the new substance that is going to form, it is going to have a different formula. Okay, particular formula, fixed formula. Like
Okay,
we
sir.
are dissolving sugar in water, it does not have particular formula.
Done, sir.
So let's have some question over it. From where you are studying right now, Gauri?
Like from where I am living, UAE.
Right now, you.
Done, sir.
Just a minute that I'm finding the questions for you. Okay, just give me a second. Okay, here it is. So what's the answer for the first, this one, second one?
Answer C, corrosion, and it is a chemical change.
Good. Question number third, six, sorry.
Sir A, first, second, third.
First, second, third.
Sorry, no. First, third, and fourth.
Hmm. Testing of
C.
iron is not a physical change, it is a chemical change. Question number seven.
So first and second.
First and second. A. Chemical
Yeah.
change is burning of wood and decaying of wood is the correct answer. What do you mean by words sawing of wood?
Said
Have you heard about this saw? Saw is RE that woodcutter used to have, or the carpenter used to have to cut in order to cut. So that is called saw. And sawing means cutting. Okay, so for the when we cut the wood, we you don't use the wood as cutting of wood. It is sawing of wood. Okay. Next one
okay, sir.
is hammering of iron nail into a piece of. So because we are when we are hammering an iron nail, it will simply results in means no new substance is going to form there, na? Because iron nail is still magnetic. It will show the property that it was showing previously. It is still good conductor. Previously, it is good conductor. It's still good conductor. You can conduct it, electricity to it. So that will show the same property. So that is not a new substance form. So let's move to the next part for this chapter. Just a minute. Let us start with that. Gauri, that you have already told me that what is matter. So matter is simply anything that occupies space and has mass is called matter. That you have heard. Now we shall be going to divide this matter into C means we shall be going to study about the matter because matter in our surrounding is the name of the chapter. So what we see matter in our surrounding that can be you can see the same in different forms. Like for example, if a teacher came in a class, okay, so means simple if I'm saying that you need to classify the students in your class in a particular group. So you can categorize them on the basis of their genders. Males comes under one category and female comes under one category. Same students can be categorized as uh, on the basis of their marks they obtain. Like 100 to 90% will come under one category, 90 to 80% will comes under one category, 80 to 70% will comes under one category. And same students can be categorized on the basis of their names, first alphabet. Like the number of students which have their name with starting with A will comes under one category. The other one which is starting with B will comes under another category. So this is the way that how can we categorize the same thing into different patterns by just changing the basis that on what basis what criteria we are using here. Are you getting my point? So like for example, if I'm saying here that uh, water H2O, I'm saying water H2O, okay. And if I'm saying oxygen gas, if I'm saying okay, sugar solution. And if I'm saying like zinc, zinc, zinc is metal. Okay. So if I'm saying that you categorize this one, so on the basis of their state, on the basis of their state, like solids, in solid you will write simply zinc. In liquids, in liquid you will write water, H2 and sugar solution. And in gaseous form you will write O2. In gaseous form you will write O2. Got it? So these substance we have divided on the basis of their states. Now the same substance, if I'm changing only the pure substance, pure and impure substance, pure substance and impure substance. Impure substance means mixtures. So if I'm saying that what are pure substance, that you will going to study in the next chapter, but now I'm going to give you a simple view that in pure substance is one which is carrying only one kinds of items, one kinds of particles, types of particles, and that have their specific property. Okay, like oxygen gas is pure substance. Zinc is pure substance because it is carrying only one zinc particles. And water is H2O. You can say that why water is pure, it is carrying oxygen and hydrogen. Just the reason behind it that oxygen and hydrogen in water are chemically bonded, because when oxygen react with hydrogen or hydrogen bonds in air, it form water. Hydrogen atoms when react with oxygen atoms, so their bonds are broken. Initially the bonds between them are broken, and the new bonds of water is formed. New bonds of water is formed. Mhm. Are you getting my point? New bonds of water are formed. So now this as a whole will act as a new particle that you will learn in the next class. Don't worry about it. Sorry, next chapter. Don't worry. But what I want to say here is that water will comes in the pure substance because still it is having two different kinds of atoms like hydrogen, oxygen, but they are not showing their different properties. Hydrogen is not showing its property, oxygen is not showing property. So we will consider it as a whole that water H2O is a one particle because it is a new substance. Okay. Like for example, a car is carrying wheel, engine, okay, seats, but we will not say that this is a different substance. Car is considered to be a single unit because it is seat alone cannot travel, engine alone cannot travel, wheel alone cannot travel for long distance. So when we combine all them, they form a car, and car is a special particle of one unit. Same hydrogen and oxygen when combined together they form water, and water is a particular specific topic. Okay, next one is impure substance. What are impure substance? Impure substance is one which is carrying mixtures like sugar solution, sugar solution, in which the different particles show different properties. Like sugar particle will show different its property, and water particle will show different property. So same thing what we are having here is that liquid, water, sugar, they can be characterized on the basis of their shapes as well as they can be characterized on the basis of their pure substance and impure substance. Are you getting my point? So same thing can be characterized in different forms, just changing their criteria on which you are dividing them. Okay. If we divide them on the basis of their states, same matters can be classified into three parts. One is solid, liquid, and gas. So whatever you see or around you, either it is solid, either it is liquid or gas. Got it? So in this chapter, we'll be going to study about the states of matter, that solid, liquid, and gas, and when solid changes into gas, what happens? Okay, why why do evaporation causes cooling effect? That you will going to study in this chapter. Okay, so let's move further and start the chapter. So write it down that matter, it is a physical state, or we can say that on the basis of physical state, we have divided this one, okay, into solid, liquid, and gas.
Done, sir.
Okay. There are the two other states of matter. One is plasma and Bose-Einstein condensate. So that will not going to study in this chapter, or this will going to study in the high classes. But just for knowledge, for the sake of knowledge, we will write this one, that plasma and Bose-Einstein condensate are the states of matter. Please note it down.
Done, sir.
Now the first property of matter. What is the first property of matter? Particle of matter. We'll simply say that particles of matter are going to have space between them. What is the characteristics? Characteristics means identity. Identity, specific. Like if I ask you that what is the characteristic of a refrigerator, that it has a cooling effect. It cools the things that is kept inside it. Okay. What is the characteristics of a mobile phone? That it has a display, it has a microphone. Same. What is the characteristics of the particle of matter? When you know that matter is made up of particles. So how does this particle really act? Are you getting my point? How does this particle really act? We will simply say that particles of matters have a space between them. Particles of matter have space between them. How will you identify this one? Particles of matters have space means how will you, yeah, how can you prove this one? Is there any idea? Sorry? No. Like for example, if I'm going to explain this one, like if you have a beaker, okay, and you take 100 ml of water inside it, like it is marked with 100 ml, and then you add some sugar to it. Then you add some sugar to it. This is water initially, 100 ml water, and then you add some sugar to it. In the corner, 2 or 3 tablespoons of sugar, you added it. Then slightly, you will find that the level of the water will rises up. The level of the water will rises up a little bit because of the sugar is not dissolved. Okay, sugar is not dissolved. But when we are just okay, but when the sugar is dissolved, after the sugar is dissolved, you still you stir this solution, okay, and after the sugar is dissolved and it goes into the intermolecular space, sugar get dissolved, then the water level rises, which was earlier rises here, it got risen. Why it got risen? Because there is sugar in the bottom and there is no water at that point where the sugar is occupying the space. Because of that, the level of the water rises. But when the sugar goes into the intermolecular space of water, then simply what would happen? Can you guess? The level of the water will become same. Okay, level of water reaches to its original level on adding some undissolved sugar. What? The level of the water rises. Okay, but when you dissolve it, after dissolving, the level of the water reaches to its original value. Okay, so please draw this one. You done?
Yes, sir.
Please note it down properly in your notebook. When we dissolve salt in water, the particles of water get into the space between the particles of water. And when salt get dissolved, no increase in volume is seen. Okay.
Done, sir.
Okay. So what you have learned, if I'm asking you till yet, tell me, can you tell me that how will you be able to prove this one that particles of matters have a space between them?
So, like when if we take water, like 100 ml water and the sugar. So
Hmm.
when we dissolve the sugar in the water, the
Okay.
level of water didn't increase because there is like a space between the particles in the particles of water. So that sugar get fitted inside those like particles and all.
Particles of matters are continuously moving. Particles of matters are continuously moving. This is the next property that how can we say that particles of matters are continuously moving? They are continuously moving. Do you think that the particles of solids also continuously move? They vibrate about their mean position, okay? But they
Okay.
are not continuously moving. Okay. Now, what I'm saying here is that the particles of matters are continuously moving. That's you can understand with the help of crystal of potassium permanganate. Potassium permanganate. When you add potassium permanganate crystals to water, these are purple color. Okay. So after some time, you will notice that the whole water will become purple. The whole water will become purple. The whole water will become purple. Why it is so? Why it is so? Because particles of matters are continuously moving. They are continuously hitting the crystal of particles, crystal particles, and then taking away, taking away. Okay, so the particles of water are hitting continuously and then taking away the particles of potassium permanganate. Okay, and thus after some times it will becomes how it is will become the whole solution will become purple. Are you getting my point? Next thing is very simple here is that You have been studying that kinetic energy is responsible for the motion of anything. If something has motion, it means it has kinetic energy. And you know that kinetic energy is directly proportional to heat. Means more the kinetic energy, more will be the heat because the particle heat. Or we can say more the heat, more will be the kinetic energy. So if we take these two beakers, one is hot, another one is cold. And we add potassium permanganate to it, KMnO4. We will notice, we will find that the diffusion rate or the dissolving rate is faster in hot water rather than cold water. Let me show you with the example. You can check it here. That one is having hot water and one is having cold water. The first one is cold, another one is hot. So when he is adding potassium permanganate to it, you will notice that whole the solution will become purple, but it will be slower in cold water than and faster in hot water. Okay, we'll see that after some time the whole water will become purple, indicating that particles of matters are continuously moving because they are moving, they are hitting. Particles of water hit the potassium permanganate crystal, will take up the particles of KMnO4, and then it will go into intermolecular space, and then it will be showing like this. Are you getting my point?
Yes, sir.
So this is the similar question came in the examination, that why do the food kept in the refrigerator, means the smell of the cooking food reaches at faster rate than the food kept in the refrigerator? Same answer, because when food is being cooked, it is having high kinetic energy because it is hot. Hot particles of food will travel larger distance because they have more kinetic energy. They will travel at faster rate. They will go and hit every corner of the house. But the cold food, if it is kept in the refrigerator, you put it on the table, the cold food. Then in that case, they will not travel faster distance or larger distance, just because the simple reason, just because they are having uh, means they are having low kinetic energy because it is cold. Okay, are you getting my point?
Yes, sir.
So please note it down. Note it down. Please draw this one. Note down topic: particles of matters are continuously moving.
Done, sir.
Okay. Please write the statement only. With the help of uh, example, illustrate that particles of metals are continuously moving.
Done, sir.
Done. Have you noted up to here?
Uh,
So,
till
Gauri,
when?
can you, up to where you have noted? Up to here you have
Like
noted?
I have, uh,
Up to where you have noted?
such, there are several examples such as
Up to here,
till there. Yeah. No, no, no.
such as, write
Yeah.
down the examples now. Smell of the
Example.
cooking food.
Okay. Okay, sir. Done.